Today's video, I'm going to show you how to recrystallize a solid material, and recrystallization is used as a purification method for solids. So I have a sample of 2-nitrobenzoic acid here, and I'm going to show you the procedure we're going to follow to do this recrystallization. It looks relatively simple, but the difficulty that comes about in a recrystallization is that you have to make a judgment call as to how much solvent you need to use. If you add too little, the material recrystallizes too quickly, and you haven't really purified your material. If you add too much solvent, then material does not recrystallize. I'm going to use water as our recrystallization solvent. I'm going to turn this hot plate on. Now the point is not to get the recrystallization solvent boiling. We want it to be hot and just below the boiling point, so that we don't, so we can control the heat a little bit. Okay, so in a recrystallization, there are two ways to add your material to your Erlenmeyer flask. You can simply take your weighing paper, fold it up, pour it in. Oftentimes for a small Erlenmeyer flask, you're going to probably spill some of that. Alternatively, you can use a powder funnel, which has a wider opening, and that allows you to pour it in very easily. Okay. Once you've added your solid to the Erlenmeyer flask, you can begin to add your warm solvent. So it may take a little while for the water to heat up. I have several things here that I can talk about while that's working. I have basically a wooden stick, which I'm going to use as a boiling stick, so that when I add solvent to the 2-nitrobenzoic acid, that we can prevent this phenomenon called bumping, which is where material will vaporize too quickly and it will force the liquid out of the container. I also have a transfer pipette, which is going to be used to transfer our solvent to our Erlenmeyer flask. So the idea of recrystallization is to have the minimum solubility, preferably no solubility, in the solvent you're using at low temperature. So at room temperature, you do not want your compound to dissolve at all. But when we heat the solvent to, in this case, close to boiling, and we add it, we want this compound to be have maximum solubility. So what will happen is we'll add the hot solvent to our compound. It will dissolve at a high temperature. We'll remove it from the heat and put it on the counter and let it cool slowly. And as it cools, the solubility decreases. Okay, the solubility will decrease as the temperature is lowered. And that's going to cause our material to crystallize out. And if it crystallizes out slowly, then we got a more pure solid, which is the purpose of this technique. You can start to see that the solvent is heating. It's not boiling, but you can start to see the condensation on the side of the Erlenmeyer flask, and we're getting to the point where we can start to add this to the compound. So I'm going to take some of this material using my transfer pipette, and initially what you want to do is simply add enough solvent to cover the solid that you have in your Erlenmeyer flask. So I'm going to transfer that over. I'm going to try to get some of this stuff off the side of the Erlenmeyer. Okay, so I have quite a bit of solid here, and I've added maybe about 2 mils of water to this. You can swirl around, and now that I have solvent on my solid, I'm going to add the boiling stick to the Erlenmeyer flask. Now I'm going to put this on the hot plate. Now, since we have solvent there, we're going to try to heat this up to where it has just a gentle boil. Okay, so we start to see this start to bubble, and we're going to wait a couple of seconds. And if the compound does not dissolve, okay, so we'll keep swirling this. If the compound does not dissolve, then that means there's not enough solvent there, and we have to keep adding more. Okay, so I'm going to add another approximately a mil of water. Okay, and as you can see, what you'll notice as we continue to add solvent is that this cloudiness will go away, and we're starting to see some of the solvent, the solute, this compound dissolve, and we're getting a brown solution. This is a light tan solid initially, so you start to see that this is going into solution. Okay, keep swirling it. You can pick it up, get some of that stuff off the side. Okay, so as you can see, this was non-soluble initially, and it's not soluble at room temperature, but when you start heating it, it becomes very, very soluble in water. This is enough solvent. Now, what we want to do is if we take this off, it may recrystallize too quickly. So I'm going to just add another milliliter or so of solvent. That's just to give us a slight excess, because as we're heating it, we're also evaporating some of the liquid. So now that that's all dissolved, I can essentially set this on the countertop, and I can remove the boiling stick if you prefer. And this will be a good recrystallization solvent if the crystals start to form within 10 to 20 minutes, give or take. The slower the crystal formation, the better. If the crystals form too quickly, that means you trap the impurities and you really haven't purified your material. The slower the crystal forms, the more pure it is, the better the melting point. Okay, so at this point we simply have to wait for this the crystals to form. So when your recrystallization has occurred, you can complete your recrystallization by cooling the Erlenmeyer flask in an ice bath for about 5 minutes. After the 5 minutes, you can recover your crystals by using a vacuum filtration.